Hi guys, welcome to Crack Easy, the place to learn how to crack easy exams. It's me Abhisha. Today we are going to solve GATE 2003 and 2004 questions on Fourier Transform. Stay tuned to the session as I'm going to share not only the answers but also all concepts, tips and tricks related to each question. Have you subscribed this channel? If you haven't, please do it and don't forget to press the bell button. Hope all set to get started. The first question I have for you is from GATE 2003. Let x of t be the input to a linear time invariant system. The required output is 4 into x of t minus 2. The transfer function of the system should be. 4 options are given. Option A, 4 e raised to j 4 pi f. Option B, 2 e raised to minus j 8 pi f. Option C, 4 e raised to minus j 4 pi f. And option D, 2 e raised to j 8 pi f. So here we have an LTI system. Its input is given as x of t and output as 4 into x of t minus 2. We are asked to find out transfer function of this system. First of all, let us understand what is an LTI system and how can we define transfer function of an LTI system. Do you know what is an LTI system? Any guess? Alright, a system which satisfies linearity and time invariance properties is known as a LTI system or a linear time invariant system. You can see the block diagram of an LTI system here. X of t is marked as its input and y of t as its output. Now, can anybody tell me what is impulse response of this LTI system? How can we define the impulse response of this particular LTI system? Any guess? Alright, the impulse response h of t of this LTI system is defined as y of t by x of t, where y of t is the output and x of t is the input. Hope you got it. Now we are going to take Fourier transform on both sides of this equation. I hope you all know that Fourier transform of h of t is represented by h of e raised to j 2 pi f and that of y of t is represented as y of e raised to j 2 pi f. Finally, Fourier transform of x of t is represented as x of e raised to j 2 pi f. Alright, when we take Fourier transform on both sides of this equation, we get h of e raised to j 2 pi f is equal to y of e raised to j 2 pi f divided by x of e raised to j 2 pi f. Now tell me, what is this h of e raised to j 2 pi f? Any guess? It's nothing but transfer function of the LTI system. H of t is known as impulse response and its frequency domain representation h of e raised to j 2 pi f is known as transfer function, which is mathematically defined as y of e raised to j 2 pi f divided by x of e raised to j 2 pi f, where y of e raised to j 2 pi f is the Fourier transform of output and x of e raised to j 2 pi f represents Fourier transform of input. In our question, we have an LTI system with input x of t and output 4 into x of t minus 2. We are supposed to find out its transfer function, that is h of e raised to j 2 pi f. So let's do that. Since the output of the system is given as 4 into x of t minus 2, we can write y of t is equal to 4 into x of t minus 2. Now we are going to take Fourier transform on both sides of this equation. As you know, Fourier transform of y of t is represented by y of e raised to j to pi f. But what about this 4 into x of t minus 2? We know Fourier transform of x of t is x of e raised to j to pi f. How can we find out Fourier transform of x of t minus 2? For determining Fourier transform of x of t minus 2, we are going to use time shifting property of Fourier transform. So now have a look at what is time shifting property. If x of e raised to j to pi f is the Fourier transform of x of t, then Fourier transform of x of t minus a is e raised to minus j to pi f a x of e raised to j to pi f, where a is a constant. Got it? This is our equation. Y of t is equal to 4 into x of t minus 2. So when we take Fourier transform on both sides of this equation, we get y of e raised to j to pi f is equal to 4 into e raised to minus j to pi f into 2 into x of e raised to j to pi f. By rearranging it, we get y of e raised to j to pi f by x of e raised to j to pi f is equal to 4 e raised to minus j for pi f, which is nothing but our desired transfer function h of e raised to j to pi f. Thus, our answer is 4 e raised to minus j for pi f. That is option C. Let us move ahead and see next question. It's from GATE 2004. The Fourier transform of a conjugate symmetric function is always option A, imaginary, option B, conjugate symmetric, option C, real, and option D, conjugate antisymmetric. Before starting the solution, let me ask you something. Do you know what is a conjugate symmetric function? Any guess? Suppose we have a function x of t, then it is said to be a conjugate symmetric function if it satisfies the condition x conjugate of minus t is equal to x of t. Clear? If x of t and x conjugate of minus t are equal, then that can be considered as a conjugate symmetric function. In our question, we are asked to find out nature of Fourier transform of conjugate symmetric function. And for that, we are going to use a property of Fourier transform which is known as conjugate symmetric property. According to this property, if x of t and x of f are Fourier transform pairs, then x conjugate of minus t and x conjugate of f are also Fourier transform pairs. In other words, we can say that if x of f is the Fourier transform of x of t, then x conjugate of f is the Fourier transform of x conjugate of minus t. Now we are going to combine these two facts for finding nature of Fourier transform of conjugate symmetric functions. Here we are dealing with a conjugate symmetric function, that is x of t is equal to x conjugate of minus t. According to the property, if Fourier transform of x of t is x of f, then that of x conjugate of minus t is x conjugate of f. Since these two signals are equal, we can equate x of f to x conjugate of f. If a signal and its conjugate are equal, then it should be a real signal. So we can conclude that Fourier transform of a conjugate symmetric function should be real. Thus our answer is option C. Hope you got it. Let me now take you to next question. It's from GATE 2004. Let x of t and y of t with the Fourier transforms x of f and y of f respectively be related as shown in figure. Then y of f is. 4 options are given. Option A, minus 1 by 2 x of f by 2 e raised to minus j pi f. Option B, minus 1 by 2 x of f by 2 e raised to j 2 pi f. Option C, minus x of f by 2 e raised to j 2 pi f. And option D, minus x of f by 2 e raised to minus j 2 pi f. Here we have two signals x of t and y of t. How they are related, that is illustrated in this figure. In fact, we have to find out how the Fourier transforms are related. So let's do that. First, what we need to do is we need to find out the mathematical relation between x of t and y of t based on this figure. This is our x of t. Now what we are going to do is we are going to perform time shifting operation on this signal. I hope you all know how to perform signal operations like time shifting, time scaling, flipping, etc. When we shift this signal to left by 2 units, we get its time shifted version x of t plus 2, which look like this. You can see x of t and x of t plus 2 are same in shape, but there is a time shift between them. Alright. Next we are going to scale this signal x of t plus 2 by a scaling factor 2. When we scale this signal by a factor 2, we get x of 2t plus 2. Now, can anybody tell me how to obtain the waveform of x of 2t plus 2 from this waveform? Any guess? Alright, if we replace all instances of t in x of t plus 2 with t by 2, we get the waveform of x of 2t plus 2, which look like this. Finally, we are going to flip this signal along x-axis. After performing flipping, we get minus x of 2t plus 2, which look like this. Now you look at the waveforms given in our question. This is our y of t and this is our minus x of 2t plus 1. By comparing these two waveforms, we can conclude that y of t can be mathematically expressed as minus x of 2 into t plus 1. Alright, thus we obtained a mathematical relation between x of t and y of t. What is our next task? We have to find out how their Fourier transforms are related, and for that we are going to take Fourier transform on both sides of this equation. As you know, Fourier transform of y of t can be expressed as y of f. But what about this x of 2t plus 1? We know Fourier transform of x of t is represented by x of f. How can we find out Fourier transform of x of 2 into t plus 1? In fact, for determining the Fourier transform of x of 2 into t plus 1, we need to use some properties of Fourier transform. So, now have a look at some properties. First, we are going to focus on scaling property. According to this property, if x of f is the Fourier transform of x of t, then Fourier transform of x of at would be 1 by mod a x of f by a. In other words, we can say that if x of f and x of t are Fourier transform pairs, then x of at and 1 by mod a x of f by a are also Fourier transform pairs. Based on this, we can write the Fourier transform of x of 2t as 1 by 2 x of f by 2. Got it? Let me now take you to shifting property of Fourier transforms. According to this property, if x of t and x of f are Fourier transform pairs, then x of t minus t0 and e raised to minus 2 pi f t0 x of f are also Fourier transform pairs. And based on this property, we can write the Fourier transform of x of 2 into t plus 1 as e raised to minus j 2 pi f into minus 1 into 1 by 2 x of f by 2, or e raised to j 2 pi f by 2 x of f by 2. So we can conclude that Fourier transform of minus x of 2 into t plus 1, that is y of t, is minus e raised to j 2 pi f by 2 x of f by 2. Thus, our answer is option B. So, this brings me to the end of the session today. Hope you all enjoyed it. Thanks for watching. Thank you.